tunjukkan dekat senarai ni, we have a 31. Okay, you have a 31 classmate in this class, but now we have a 27. But never mind, we will proceed on this class. So today we are going to the chapter 3. But before that, how are you? Apa khabar semua?
Khabar baik, Doktor.
Okay, boleh dengar tak suara saya dengan jelas? Saya risau internet juga. Jelas juga. Ni pelik ke apa saya ni? Okay, Lee. Alright, so okay. So now we are going to the chapter 3, okay? Okay, so open your books, your notes. Alright, okay. Okay, so today we are going to the topic 3. Still in topic 3. Peranti electronic devices. Okay. So we have last time we have a class for the topics which is the power supply, oscillator, thyristor, and we also have a ADC converter and DSC converter. And we also study about the diode. Okay. If questions came out, why we learn a diode? Okay. Why we learn the diode? Anyone to answer? Why we learn the diode? Anyone? Zaini? Kenapa kita belajar diode? Because diode, okay, you have answer? Okay, tak ada salah, tak ada betul pun. Okay. Okay, why we learn a diode? Why we learn a topic of diode? Okay, because diode is the component which is have a IV curve, IV characteristic. So that's why we learn the diode. Diode is the unique topic, and we have learned its topic focus on diode only because the diode have their own IV characteristic, their own IV curve. Okay. Okay. Did you still remember that we have learned about the diodes IV characteristic? Okay. So that's why we learn the diode. Focus on the subtopics for these topics. Okay. So now today we move to the transistor. Okay, why also we focus on the transistor in the subtopic? Because transistor also have a IV characteristic, have a IV curve for these for these components. Okay, so transistor, we have two types of the transistor. Okay, the first one, that is the bipolar junction transistor. Okay, bipolar in Malay words, that is a transistor simpang dui kutub. Okay, in English word we call it transistor what? Bipolar junction. Okay. Okay, so this is a contents what we must learn. We should learn by today. Okay, the first one is the transistor construction. The second one, we have a transistor configuration, which is include the Pnp configuration and NPN configuration. The third one, transistor IV curve, transistor operation, which is have the Pnp operation and the NPN operation. And the last one, we have a transistor application. Okay, boleh ke tak? Hari ni saya ada kat office. Tu kat belakang nampak putih je. Siapa yang baru masuk tadi tu? Mana dia? Okay. Okay. So class. Yang ni yang saya lemah. Dia mengajar masuk. Okay. Jadi so now we move to the transistor construction. Okay, how this transistor will build? Macam mana dia dibuat? Okay, so transistor is an electronic device made of 3 layers of semiconductor material that can act as an insulator and conductor. Okay, class. So transistor that can act as an insulator and also conductor. Okay, so the transistor will construct by the semiconductor metals, that is the germanium and silicon. The three-layer transistor is also known as the bipolar junction transistor, BJT. Alright? The term bipolar refers to the use of both hole and electron. Bipolar, it means that why we call this transistor the bipolar? Because it can use both. It can use kedua-duanya. Okay, both holes and electron. It means that bipolar, it can use hole, and the other time it also can act as electrons, as charge carrier in the transistor structure. Okay, so BJT, we have two types of BJT. The first one, we call it Pnp, and the second one, we call it NPN. Okay, why we call it Pnp, why we call it NPN, we can look this after this. Alright, so BJT consists of three terminal. Okay, the first one is the collector, C. The second one, base, B. And the others is emitter, E. Okay, collector pengumpul, base tapak, emitter pemancar. Okay, so why we need transistor? Okay, kenapa kita perlukan sangat transistor ni? In microphone capsule to respond to sound, electric guitar pickup, which is respond to string vibrate, and the last one, playback head on an analog tap deck. Okay, so you can see this is the microphone. Okay, actually microphone, when we sing a song, okay, we always hear that our voice is very is here, that the sound is very clear, right? Merdu sangat kan? It's very clear, your voice. Why it's clear? Okay, why your voice clear? Why? Because the transistor in the microphone have to filter out the ripples, the noise in your voice, from your voice to the microphone. Okay, so the microphone, inside the microphone, okay, it will be filter out all the ripples, noise in the microphone. Okay, so that's why your voice it will hear clear, and it sounds orang kata apa merdu lah kan, merdu, suara merdu, your voice clear, your sounds clear. So this is the transistor have made its function that will filter out all the noise inside the microphone to come out the voice that came out from the microphone, to make sure that your voice very clear to hear. Okay, boleh Okay, jadi maksudnya dekat sini transistor dia akan memainkan peranan untuk filter out semua noise-noise hingar-hingar tu dalam mikrofon tu, dan dia bila dia keluar suara kita sedap dia dengar. Itulah salah satu fungsi transistor ini. Alright, so the next one, electric guitar pickup. Okay, as we know that electric guitar that will come out the voice, the sound, electric guitar kan, it will come out the sounds of the guitar is quite the noise is quite high, right? So in this case, transistor will have to ripple out all the noise which is in the electric guitar. There will ripples all the noise also in the electric guitar, so that you will hear the noise, the electric guitar vibrate, it moves smoothly. Okay, so transistor, it will be help the guitarist when the guitarist use this electric guitar. So the transistor will help to repulse all the what we call to repulse all the sound, to all the noise of the vibrate of the electric guitar inside the guitars. Okay, so the third one, playback head. As you can see, this is a playback head. So this playback head that will respond to the magic field on tap. Okay, so boleh tak setakat ni? Kejap ya, ada student saya nak jumpa. Dia nak tanya dia dah sampai mana, dia takut nak jumpa saya. So far boleh faham atau tidak?
Boleh, Doktor.
Siapa ni? Okey. Itulah kan, bila kita WhatsApp orang, Assalamualaikum, awak ni kan semua cikgu kan, akan keluar nanti kan. Bila WhatsApp sesiapa lah kan, Assalamualaikum, saya Idayanti, kalau saya lah, saya Idayanti, saya dari FTV, saya dari RMIC. Tujuan saya WhatsApp ni adalah untuk saya minta produk dari doktor. Contoh tu saya lah. Kalau saya WhatsApp orang kan, cuba kalau WhatsApp orang, kenalkan diri kan. Awak kena tahu tau, tak semua orang save number kita, tak semua orang bajet kenal kita. Ya, sebab awak pula ni semua cikgu, lagilah terkenal dengan nilai-nilai murni kan. Bila when you text someone, you introduce yourself. I'm who? For example, as me, I'm Irdayanti. So the purpose I'm text you because I want you to submit the proposal to me. Kena macam tu bila WhatsApp orang kan. Perkenalkan diri, kita janganlah bajet kita Siti Nurhaliza, Zainazin kan. Semua orang kenal kita, save number kita kan. Kadang-kadang biar pun orang tu save number kita, tapi kita kenalkan diri. Nampaklah kan kita punya adat susila tu kan. Tolong semua saya suka sangat nak ingatkan pelajar-pelajar saya supaya memupuk nilai murni, nilai etika dalam diri masing-masing. Sebab saya nak sangat tengok besok akan datang kalau saya pergi sekolah, observe junior awak, saya tengok awak adalah pelajar saya tu yang saya selalu ingatkan pasal nilai-nilai murni ni. Tolong ya, sebab apa yang kita amalkan pada hari ni, etika kita pada hari ni adalah cerminan kita pada masa depan. Itu yang saya selalu ingatkan. Terutama kamu semua keluar nak jadi cikgu ni. Cikgu macam-macam ni ada ni. Cikgu ERT, cikgu Sampetanya, cikgu RBT, cikgu RC kan. Jadi keluar besok kan nilai-nilai murni tu kena ada. Okey, boleh. Kalau nilai murni tu, profesionalisme tu ada pada hari ni, akan datang bila dah jadi cikgu. Ni siapa baru masuk ni? Kalau masuk lambat saya tak marah, cakap doktor maaf masuk lambat, lain tak ada. Boleh kan? Cakap macam tu, betul tak? Boleh kan? Sebab awak cuma cikgu kan? Sedangkan saya pun kalau meeting sesama saya. Apa? Kenapa? Kira?
Maaf doktor, belum masuk. Saya ada ni, hari ni saya ada ni latihan industri.
Awak ada data industri? Data industri apa?
Maaf ya doktor, saya dengar tidak masuk rapat.
Tak ada kelas kami. Meh, saya cok-cok kita selesai. Awak ada data industri, ambil masa saya, kenapa?
Tak. Saya bawa balik ni.
Yelah bawa balik. Kelas saya pukul 4 mula. Kelas saya bukan pukul 5 mula kalau dah nak
Sebab
buat.
biasa kan kelas pukul 5.
Tak ada biasalah. Luar biasa ni. Sini saya sign Sekejap pelajar master saya datang. Tanda tangan nama dah cop Sini saya Betul. Bismillahirrahmanirrahim. Nak buat kerja 2 kali dah ni.
Itulah. Tak tahu pula Dr. Wen tak boleh sign kat situ. Dia sign je.
Bismillahirrahmanirrahim. Jadi bila nak hantar vendor ni?
Yang menang ni. Rekton.
Ni siapa? Kawan Dr. Salisu
Mungkin tu.
Rekton.
Dr. Salisu yang uruskan.
Yang ni?
Saya uruskan yang nombor 2 ke nombor 3 punya tu. Quotation. Yang 2 Dr. Salisu.
Siapa yang akan buat IoT ni
Syarikat rektor ni dia kata dah hantar PO semua dalam tempoh sebulan, dia datang dia pasang dia.
4,200
Kira yang paling murah lah. Yang lain ada 6,000.
Yalah.
Actually sebenarnya dia kata macam ni.
Nani saya nak ambil quotation ni boleh Nani?
Boleh.
Okey sebenarnya apa?
Tak tahu lah Dr. Wan kata bajet tak cukup banyak sebenarnya kan. So macam ada pokok yang mungkin tak menggunakan sensor. Macam mana tak saya pun tak faham.
Dia macam ni je sebab nak buat watering. Projek Dr. Salisu ni, projek saya, dia tanya pandangan saya sebelum dia berhenti. Dia duduk di sebelah ni je. Dia nak mohon grant. Dia tanya saya nak buat projek apa yang berimpak untuk saya pertanian. Saya kata guna IoT lah. IoT tu watering. Jadi maksudnya kalau nak ikutkan dia ni, itulah saya nak tengok nanti dia sampai barang. Dia sepatutnya Nani, saya bagi gambaran dekat awak lah. Dia sepatutnya satu produk, dia akan flow. Semua tanaman tu dia akan dapat watering tu. Kenapa tak cukup pula? Dia buat satu je sepatutnya dia akan sistem tu akan jalan semua.
Yang ni lah siapa quotation nombor 3 yang saya buat tu dia kata satu untuk satu pokok macam mana tak?
Kenapa dia buat satu pokok matilah macam tu?
Tu yang saya
pokok banyak tu.
Mana ke dia punya?
Patutnya dia letak satu je pacak kat tangan. Okey, set IoT. Pukul 5 pokok siram. Pukul 5. Okey, so watering semua. Pukul 5. Pukul 8 malam watering semua. Itulah jimat kos. Kenapa nak kena buat satu tu dia guna hitam tu ke pengairan dia?
Maksudnya
tu saya nak kena take care. Tak apalah, saya tak nak masuk campuran ni. Tak nak. Awak pun saya tak apa.
Nanti kalau dah sampai doktor nak tengok dia punya.
Tak apa, tunggu dia pasang dulu.
Doktor sekali kan terlibat dengan
saya, yelah dah saya bagi idea dekat Dr. Salisu, mesti nama saya ada kan. Tapi saya tak bajet pun masuk, saya cuma bantu kawan-kawan je lah. Dia punya nama itu kan. Sebab dia tak dapat geran masa tu, KPI dia kan untuk dapat geran, kotak dia kena terminate. Tapi kena terminate juga.
Terminate juga
Pedro memang dia berhenti. Dia mungkin dapat mengajar kat tempat lain tu. Itulah kesian lah Hais. Tolong kawan-kawan nanya kan.
Dr. Wan minta saya buat satu paper berkenaan IoT. Kan macam
itu dia punya konsep. Kalau nak buat paper IoT tu, konsep dia macam tu. Kalau nak buat paper IoT,
Dr. Wan minta untuk
janganlah Nani, saya cadang kat awak buat paper develop IoT tu berfungsi. IoT tu budak kejuruteraan betul dia boleh buat.
Maksudnya kalau saya nak
buat paper macam mana pembangunan IoT tu. Kan awak belajar. Saya tengok ramai kawan-kawan awak. Saya reviewer jurnal dia. Saya tengok. Saya tengok ramai kawan-kawan awak. Dia kena buat face tau. Face. Awak buat face. Model ADDIE. Study AD tu. Nanti tanya SV awak. ADDIE tu analysis macam mana, D macam mana, design macam mana, develop macam mana, I implement last evolution. Itu buat macam tu. IoT step punya IoT. Itu saja. Bukan IoT tu cara pasang, cara troubleshoot. No, itu budak kejuruteraan. Kesian dekat awak nanti. Tak boleh. No, awak tak boleh buka bidang awak. Jangan seksa diri. Buat development je. AD.
Development of AD lah. Lepas tu kaitkan dengan
IoT. Ya, bahagian development tu. Develop produk IoT. Itu je lah cadangan saya. Ya?
Kait dengan pertanian.
Yelah, macam develop tu nanti sampai dekat develop tu masuk IoT dalam tu. Penggunaan mengaplikasikan IoT dalam tanaman. Kan saya pertanian kan. Itu Ira pada saya. Bukan buat IoT tu everyone macam mana nak buat. Kan tu kerja redtone tu.
Oh, tu bila Dr.
Nani salah tu Nani.
Okey, macam mana tu?
Bukan bidang jangan Nani nanti susah. Bye, Assalamualaikum. Saya ada kelas. Okey, korang jom kita sambung balik. Bye Nani. Jumpa lagi. Okey, Nani. Sorry Nani Okay, bye. Okay. Jadi kita masuk dekat sini. Okay, so we are going. Okay. Saya minta maaf semua. I'm sorry. Okay, because my postgrad student coming to sign her document. Alright. So we move to the transistor symbol. Okay. So what we have learned just now, we have two types of transistor. Okay, the first one we have for NPN, and the second one we have the PNP transistor. Okay, what is the differences between the NPN and the PNP? Mendengar tak suara saya korang?
Boleh.
Kakak suara korang. Okay, so NPN. Okay, why we call it NPN? Because the emitter going down, flow out from the transistor. Okay, so you can see this is the emitter flowing. So this is a flow of the electron flow out from the transistor. So we call it the NPN. Alright? Okay, so the next one PNP. Okay, why we call it PNP? Okay, because the electron will going up, will move to the transistor, to the inside of the transistor. Okay, alright? Okay, so that's the difference between the NPN and the PNP. Okay. Okay, so we move to the transistor configuration. Okay, so for this one, okay, I'm not encourage you to prove this formula, but it is because to prove the formula, it was not on your field. This is the engineering field. But you as a teacher, for me, that's enough if you just know this formula only. Okay, you just remind this formula only. Okay? Okay. Alright. So this formula only. You remind this formula only. Okay, this is the so this is the formula that you must remind, you must understand. IC equals to IE minus IB. Okay? Okay class, so this is the formula you must remind for yourself. Alright guys? Okay. And this, the second one. Okay. IE equals to IB plus IC. Okay class, is that same with the previous we have learned? IE equals to IB plus IC. Is that the same formula? Sama tak? Sama ke tak? Sama lah kan? IC sama dengan kan IE minus IB. Macam awak belajar dulu matematik. Dah lupa positif pergi sebelah jadi tolak. Kan? Okay, boleh Okay, diam tu. Tahulah tu. Alright, so we move to the next slide. Okay, this is also, you have to remind the formula for this statement. Diam je ni semua setuju lah tu. Saya anggap semua pandai lah kalau diam kan. Okay, so we look at this one. Sorry. Okay, so for this one, beta is equal to IC over IB. IC divide by IB. Okay, so for this one, beta equals to IC divided by IB. So this is a second formula you have to remind for this questions. Alright. Okay, so the next one. Okay, so now we are going to the questions to answer all the questions here. But this is the example. Example, we using the formula that we have to remind just now. Okay. Okay, you have to remember that we have a two formula that you have to remember. Okay, as we have learned just now. Okay, so the first one is the first question. A bipolar NPN transistor has a DC current gain beta value of 200. Okay, so it means that the beta value is the 200. Okay, so the beta is equal to 200. Okay. Okay, alright. So the second one, what the question given? Okay, so calculate the base current IB. Okay, so soalan minta base current IB, kan? So what is the base current IB? We don't know this. Okay, required to switch a resistor load of 4 milliampere. Okay, what is the resistor load? Resistor load is the IC. IC is the 4 milliampere. Alright. So as we have remembered that beta is equal to IC divided by IB. So in this case, we want to find IB. Okay, alright. So what is the IB? So IB is equal to IC divided by beta. Okay, so IC is 4 milliampere. Okay, milli is also stand for 10 times negative 3. Okay, belajar tak fizik? Tera, giga, mega, kilo, desi, senti. Awak belajar kan fizik dulu ataupun sains? Tera 10 kuasa Tera 10 kuasa 12, giga 10 kuasa 9, mega 10 kuasa 6, apa lagi? Tera, mega lagi. Awak belajar kan? Okey. Mili 10 kuasa negatif 3. Okey, awak cuba bahagi 4 times 10 subscribe negative 3 divide by 200. So what you get? If you get 20 times 10 subscribe negative negative 6 ampere. So this one is also the correct answer. Okay, because microampere also 10 times 3 negative 6. Okay. Oh, sorry. Micro also 10. Okay. Up to negative 6. Okay. Okay. So if you answer this answer, so it's also right. Okay. Okay. So we move to the next slide. Okay. So we move to the next questions. Okay. So this is a 3 formula. The third formula you have to also have to remind. Okay. Also have to remember. Right? This is the third formula you have to remember. Okay. So IB is equal to VB minus VBE divided by RB. Okay. So have you know the transistor have a IV curve, have the IV characteristic. So VBE must be equal to 0.7. That is a static value for the transistor and also the diode. If you have a question for diode, VBE must be 0.7 value. Alright? VCE also 0.7. If the equation include the E, VBE, VCE, VEE, the value must be 0.7. Alright? So the VB is the 10 volt. In this question, the question have given VB is the 10 volt. And the RV is 100 kilo ohm. So you're using this equation, this formula, so you will get the answer 93 microampere. Ampere, this is the units for the I, okay? For the current. Okay, as you have learned before in electric class, okay? If you want to calculate the voltan, that is the V at your last value, okay? So in this case, that is the current, so that is the A, ampere current. If you answer 93 times 10 kuasa negatif 6, yeah? 10 kuasa negatif 6 times up negative 6 ampere. So this is also correct. Okay, guys? Okay. Okay, you going home. You take slowly your calculator and you calculate all these thing formula. Okay? So if you don't understand, don't hesitate to ask me. Okay? Alright? Okay. So this is the IV characteristic curve. As I have mentioned before, what we have to focus transistor and diode in these subtopics. It was because the transistor and diode, we have a characteristic curve. Okay? Alright. Okay, so we move to the next one, Pnp operation. Okay, what we have learned before, okay, as at the topics 1, at the semiconductor, we have learned about the N types, right? N types and P types. So N type, so the N type, what is the N type? Okay, N type is the, okay, N type, we have to build a hole in your metals, in your materials. So it is same as we have learned now. Transistor Pnp operation. So transistor in Pnp operation, we have built a hole in the metals or materials in your materials. Okay, boleh tak? Boleh tak? Lily, did you understand what I have explained this one? Okay. We move back what we have learned in topic 1, in chapter 1, the semiconductors topic. Okay, the semiconductors topic, we have learned about the N type in the semiconductors, right? N type in the semiconductor. Okay, in the N-type semiconductor, I have explained that the N-type was build a hole in the materials, in your atoms. Okay, so in this case, transistor PNP, we also build hole in the materials, in the atoms, so that we can move all the electron outside the materials or outside the atoms. Okay, we put all the electron outside and then we put it in the hole that we have built in your materials or in your atoms. Okay, boleh Okay, kita ingat balik. Okay, hole Okay, so the next one is the NPN. Okay, so NPN, P type. P type is very is very kind. Okay. NPN or p-type, they will give electron if the electron overload in the materials or in your atoms. Okay, ingat lagi tak? P-type saya kata penderma yang baik, kan? Dia akan dermakan elektron sekiranya elektron yang berlebihan. Tetapi kalau PNP dia akan bentuk hole, dia kedekut, dia akan bentuk hole dan dia ambil elektron yang berlebihan di sekitar tu, dia akan masuk ke dalam hole dalam logam tersebut, dalam material tersebut, dalam bahan tersebut. Okay, boleh tak semua? Did you understand?
Doktor,
Yeah.
bukan N-type give
N-type give. P-type apa?
menerima.
Ada juga orang yang sedar Okay. Bagus. Faham lah tu. Kan? Okay. So P dia akan bentuk hole kan? Betul tak? Ni semua ni dengar sambil memasak ke?
Ya, betul.
Dengar sambil main hoki ke? Okay? Boleh? Faham tak?
Faham.
Diam je kan? Okay, jadi P Okay, so Lee, are you there? Are you listen to me?
Oh, yes, doctor.
Okay, Lee. Okay. That's the rumus I have teach you just now. I just want to look that you concerned or not what I have learned, what I have explained to you, and I've made differentiate before the class, the previous class and the class today. But you are very lucky because one of your friend was concerned about this wrong learning.
Okay, doctor.
So what you understand, Lee?
I think I need after this class, I need spend some time to learn this transistor from the learning material.
Okay, Lee. Okay, class. This is the true one. This is the exactly. Okay. The
Okay.
P-type. Okay, they will build hole. Okay, so they will accept all the electrons outside there and then they put it in the hole. Okay?
Okay.
Boleh? Okay, so N negative. Betul tak? Okay, so for the N-type, Okay, so for the N-type electron, okay, they will give the electron from the atom to outside the atoms. Okay, ingat tak? Okay, boleh tak? Ingat tak? P. Okay, P is
Boleh.
okay, P they will build hole, but N they will give electron to the outside the materials, the atoms. Ingat tu that's the key for the NPN or PNP. Okay? Okay, Zenzi, that's the key. Ya, ada soalan? Ya, Zaini, saya tak dengar. Okay, kalau NPN negatif, positif, negatif. Yep, ya. Bagus, soalan yang bagus. Okay. NPN negatif, positif, negatif. Okay. Bagus. Study ni. Alright. PNP, positif, negatif, positif. Okay. Semua ni pelajar pandai-pandai dah semester 7 kan. Ni. Semester 6 Fadila, semester 6 Khairul dah semester 7. Dah ramai dah in semester 7. So just a lot in 5th semester, 4th semester. Okay, so for those who are in 7th semester, You are a senior right now. So you have to learn by yourself, by using YouTube, Google, yeah. If you want to know more about your topics, about your subject, okay? Because after this, you will become a teacher, a great teacher. So as a great teacher, great farmer, maybe like a Zenzili, kan? Okay, maybe others occupation, maybe not farmer, maybe Zenzili will become an officer in pharma here. What is there in the maybe at somewhere in China, officer in China, okay, that will be focused on planting, maybe, okay. So you right now, you have to explore more. Don't always depends on the notes, and also not depends on the class, during the class only. So you as a great teacher, a great farmer, a great officer one day, so you have to learn by your own self. Yeah, you try searching in YouTube, you try searching in the internet, Google's, other sources, what you have learned. Okay, so I hope my students, all my beloved students also have the keep going to study, to know more about what we have learned, about what were topic, what we have learned. Okay, so guys, we move to the next one, transistor application. Okay, so this is the application of the transistor. Okay, as you can see, the application for the transistor, we can apply it as the amplification. Okay, so the next one, we also can use the transistor as the switching. Okay, open switch, it means that your circuit will be off. Okay, if close switching, it means that your circuit will be on. So as you can see, your bulb, your lamp will be shining because it close switch. Okay, close switch, it means that your circuit will be on. But if open switch, your circuit, it will be what? Will be apa?
Will be off.
Pandai. Okay, boleh? So that's all for the BJT transistor. Anything else you want to answer me? Lee? Never mind, Lee, after class, you have to study by your own self. But if you don't know, you will text me. Okay, Lee? Sama juga yang lain kalau tak faham, study balik. Kalau cuba dulu study sendiri, sebab kadang-kadang kalau study sendiri, kita lebih faham kan daripada kita, yalah, kadang-kadang bila kita bertanya, kadang tanya saya jawab lain daripada apa yang awak querykan. Selalu macam tu lah. So, saya tak betul faham apa yang awak inginkan, yang awak nak kan kadang-kadang kan. Jadi cuba semua ni guru-guru cemerlang saya ni yang keluar nanti, cuba mengkaji sendiri, belajar sendiri, meneroka sendiri ilmu-ilmu yang ada bukan ilmu saya saja, semua yang ada ni yang awak dah belajar online ni, cuba terokai sendiri. Ni untuk semester 7 ni dah nak jadi cikgu dah tahun depan kan. Tahun ni habis je ni bulan 2, bulan 3 LM awak LM sampai bulan berapa ya? Mula LM bulan berapa ya? Aiman?
Bulan 3 mula.
Bulan 3 sampai bulan berapa?
5.
Bulan je.
Bulan 3 sampai bulan 5. Jadi bulan 11 lah konvo ya?
5.
Ya, doktor.
Okey lah. Bulan 3 sampai bulan 5 LM. Lepas tu tunggu sekejap. Masa tu kena fikirlah nak kerja apa. Macam student saya tu mengajar kolej swasta sekarang. Dan dia pun dah jadi student master saya. Tadi pagi saya call dia, tanya khabar dia. Dia tanya khabar dia, kenapa dia lama tak WhatsApp saya. Dia kata dia dah kerja. Dia kata dah kerja pun kena siapkan thesis jugalah. Jadi nanti bila dapat posting, kalau dia sempat habis master dia tu, dapatlah kenaikan tinggal gaji dia tu. Tapi tak itulah. Saya doakan semua juga macam tu lah ya. Planning untuk diri awak masing-masing. Masa ni sekejap je. Ni pun dah 1 bulan 12 dah. Dah masuk 2022 dah. Kan? Dah setingkat naik usia kita. Okey. Naik tingkat usia tak apa. Yang kalau sejajar dengan pencapaian kita. Itu rasa macam seronok lah. Kita walaupun umur kita meningkat tapi kita ada pencapaian untuk umur kita tu. Kita akan rasa gembira lah kan. Umur aku ni aku dah berjaya apa-apa. Jadi saya harap semua macam tu jugalah. Ya. Okay, so we are going to the next subtopic. Okay, which is the last subtopic for this chapter 3. Okay, so this is a transistor. We call it field effect transistor. So transistor, we have a 2 type. The first one, we have the bipolar junction transistor. And the second one, we have the field effect transistor. Okay. Saya minta izin nak minum air jap. Okay, so the next one is the field effect transistor. Copy down into English word. This is in the Malay word. So I will explain in English word. So you take down, you note down the English word in your notes. Okay, this is a differences between the bipolar transistor and field effect transistor. Okay, we're looking at the transistor Dwi-kutub. Okay, for the BJT, bipolar junction transistor, this is a Dwi-polarity transistor. Okay, BJT, that is a Dwi-polarity transistor. But FET, that is the multiple polarity transistor. Okay, so BJT, it will carry current, electron, and hole. But FET, they will carry either electron or hole. Okay? Okay. I'm repeat again. For the BJT, the first one, that will be the Dwi-polarity. D-W-I. Dwi-polarity. But FET, there will be multiple polarity. Multiple, more than one. More than two. Okay, BJT, they will carry current, electron, and hole. But FET, they will carry either electron or hole. Okay, BJT also can control the current, but FET can control voltage. Okay, the last one application, it will be the switches. The logic switches. Application for BJT, there will be the logic switches. But FET, they will become amplify. Penguat. Amplification, amplifier, that's all the same things. Okay? Okay, so that is the difference between the BJT and FET. Okay, so we going to the pro, the pro for the FET and the cons for the FET. It means that the advantage and the disadvantage by using the FET. So actually FET transistor, that is the small transistor. So the small transistor, it's have a lot of the it's quite what we call it uh, uh, the temperature. Okay, so the temperature will be high, so it will become more and more, and last one, it will explode your gadget. Okay, that's a simple word I will explain to you for the FET. Okay, but in the engineering concept, FET, that will be go deaf. But so you as a teacher, and I'm the teacher for you, I will explain to you. I will give to you the simple thing, the simple imagination to you to imagine the FET transistor. Okay, so that is the disadvantages if you using the FET transistor. If you using the FET transistor, the temperature will become more highly. And the last one, your gadget, it will be explode. That's why we not interested using the FET. Okay, boleh. FET ni dia adalah kecil. Okay, so the other one, FET characteristic, that is a smaller than the BJT. BJT is the big component. So it will be used in the big gadget or components. But FET, it will use in the small gadget or components. For example, your iPhone, what is the mini gadget? In your, maybe your fan, your portable fan, your portable lamp, your portable, whatever your gadget that is a portable, that are using the FET transistor. That's why no wonder your gadget is tak tahan lama, kan? It's not quite strong. It's not robust. That is because we have using the small components inside the portable gadget. Itu beza dia tu. Okay, so that's the difference between the FET and BJT. BJT we use in the big gadget, not the big one lah. But it's not portable. For example, your laptop. Okay, if you buy your laptop, the cheaper one, I'm confirmed that your laptop, by using all the things here, using the smaller components. For example, like transistor, we using the FET. Itu je lah beza dia, kan? FET tak tahan lama, it was not robust, okay, tak kuat, tak kukuh, kan? It not everlasting. Okay, that's the FET. But BJT, that is the robust. That we can use it a long time. We can use it ever long lasting if you using the component, transistor component. Okay. So did you understand for this? Okay, so this is the last one. Okay, this is the symbol for the bipolar and the FET. So the differences between the bipolar and FET, as you can see, this is the base. Okay, this is the base. Tapak base. Okay, so this one is the This one is the ammeter. Why we call it ammeter? Because you look this one, the current flow up, kan? Okay, so this is the ammeter. And this one we call it collector, C. And this one also base. This one is the ammeter. And this one is the collector. How about this? Okay, but this is the difference. Okay, you see that this is the current flow out, right? So this is the E. This is not the base because the current flow out from here. So this is, it will be, it can be base or it can be C. Same like this. It can be C or it can be B. So this one is the E. So this one same. It will become B or C, or this one also it will be C or B. Okay guys, so that's all for today. This is just for example to give you, okay, untuk apa? Yeah.
Sorry interrupt. Boleh tengok yang kelebihan FET tadi.
Okay.
Saya tak faham yang kelebihan FET Swiss logic. Kenapa dia Swiss logic kelebihan dia?
Okay, kelebihan dia Swiss logic. Okay, the advantage for the logic Swiss. Okay, as we can see, we have learned just before, right? Open switch and close switch. Okay, that is the logic Swiss. Okay, when the switch open, so the circuit will be switch off, right? Okay, but when the switch close, so the circuit, it will be on. So that is called the logic switches. Okay, boleh?
Okay, Doktor.
Okay, bagus. Tanya Len. Okay, it's good. Okay, anything else? Zaini, setiap minggu belakang pemandangan lain-lain. Okay, so guys, ada apa-apa lagi tak nak tanya? Tak ada dah? Ya, kenapa Zaini romantik sangat? Sistem hi-fi? Oh, sistem hi-fi tu, sistem hi-fi tu kan yang bunyi-bunyi gong-gong-gong tu. Dekat kereta awak selalu tu hi-fi, hi-fi, hifi. Apa korang panggil lah hi-fi tu, hi-fi lah. Kan pembesar suara, amplifier, hi-fi. Hi-fi lah. Pembesar bunyi. Hi-fi lah. Okay, boleh? Ada apa-apa lagi tak? Ada Okay, kita ambil attendance. Fadila Wani.
Saya Doktor.
Okay. Khairul Aiman.
Saya Doktor.
Okay. Ya. Ain Syamimi.
Saya Doktor.
Syahira.
Saya Doktor.
Sem 7 lah korang. Kuratu Akila.
Saya Doktor.
Zakira.
Saya Doktor.
Mas Diana.
Saya Doktor.
Syamimi Mifdal.
Saya Doktor.
Syamimi. Amalina.
Saya Doktor.
Musi.
Saya Doktor.
Auni.
Saya Doktor.
Syifa.
Saya Doktor.
Farida.
Saya Doktor.
Maizatu Nafisa.
Saya
Farida.
doktor.
Farida minggu lepas tak datang kelas Syakira. Syakira Najwa. Awak apa tadi LI?
Saya
apa?
doktor.
Kira, awak SOAP
Apa doktor?
SOAP ke? SOEP tu ke? Kan ada korang
Macam mana?
Awak ni kan. Awak pergi SOAP ke? SOEP
Saya
tu
latihan
ke?
industri.
Awak pergi penyeliaan latihan mengajar tu ke? Latihan industri yang SOEP tu ke? Yang budak tahun akhir kena
Bukan,
buat
yang
tu.
ni pengalaman. Yang ni yang subjek pengalaman penyeliaan tu. Yang latihan industri punya.
Yelah. Yelah, tak ada masa dah ambil masa saya.
Sebab biasa kan kelas doktor pukul 5 kan.
Tapi
Saya dah habis
kadang-kadang
LR.
kelas saya pukul yelah, tak apa. Pandailah bagi masa, ya.
Sebab hari ni kan minggu
Okey.
ni dah last dah.
Tak apa. Yang penting pandai bagi masa. Tak kisah, tahu. Yang penting pandai bagi
Terima
masa.
kasih, Doktor.
Itu yang paling penting. Sama. Okey, seterusnya Imanina.
Saya doktor cantik.
Yelah. Fatihah.
Doktor.
Ha.
Doktor
Apa?
saya Farida. Doktor minggu
Ya.
lepas saya datang lah.
Ya ke?
Ya doktor.
Fatihah Hanis.
Saya
Agaknya saya panggil-panggil.
Sorry doktor.
Banyak makan. Zafira.
Saya doktor.
Okay. Mazuk. Mazuk mana? Mazuk, where are you? Pergi SOAP juga ke? Apa latihan LI tu? Takkan lah. Yelah kot. Izatu Usna. Una.
Ada.
Oh, Una. Lama tak tengok Una. Rain.
Ya, saya dokter.
Okay.
Hadir.
Umu.
Saya doktor.
Okay. Pika.
Saya doktor.
Syafawani.
Saya doktor.
Ikmah.
Ada doktor.
Dizanzi.
Yes, doctor.
Okay. Max.
Ada dokter.
Okay. Anik.
Saya doktor.
Aisyah.
Saya doktor.
Ana.
Ada doktor.
Okay. Zaini. Zaini je buka kamera. Yang lain belum tak buka kamera. Pakailah tudung. Pakai tudung je. Tengok muka saya. Kan? Okay lah. So, that's all for today. So, we see you next week. Okay, kalau ada apa-apa, tanya saya ya. Kalau ada apa-apa, tanya saya. Saya nak sangat semua. Mazul nak kena rotan ni. Baru nak masuk ni. Okay, jadi semua saya doakan semoga terus kuat lah ya. Sikit lagi dah nak ambil belajar dah. Okay, untuk semester 7 ni. So, itu saja untuk hari ni semua. Kita jumpa lagi minggu depan. We see you all next week insyaAllah. Okay, bye. Stay healthy, stay wealthy. Kaya pun nak juga. Okay semua. Bye. Assalamualaikum.
Terima kasih doktor.
Dokter. God bless.
Okay, bye.
Tunggu.